OpenAI's O1 model came out last week, and they did an extended cut where they talked to all the people who are industry experts in using the AI. And in this video, I'm going to react to what they talk about in the video.
All right, I'm Bob McGrew. I lead the research team here at OpenAI. We've just released a preview of our new series of models, O1 and O1 Mini, which we are very excited about. And we've got a whole team here to tell you about it. What exactly is O1?
So we're starting a series of new models with the new name O1. This is to highlight the fact that you might feel different when you use O1 as compared to previous models such as GPT-4o. As others will explain later, O1 is a reasoning model, so it will think more before answering your question. We are releasing two models, O1 Preview, which is to preview what's coming for O1, and O1 Mini, which is a smaller and faster model that is trained with a similar framework as O1. So we hope you like our new naming scheme, O1.
So what is reasoning anyway? So one way of thinking about reasoning is that there are times when we ask questions and we need answers immediately because they're simple questions. For example, if you ask what's the capability, you know the answer is Rome, and you don't really have to think about it much. But if you wonder about a complex puzzle, or you want to write a really good business plan, you want to write a novel, you probably want to think about it for a while. And the more you think about it, the better the outcome. So reasoning is the ability of turning thinking time into better outcomes, whatever it has to be doing. So how long have you guys been working on this?
Early on at OpenAI, we were very inspired by the AlphaGo results and the potential of deep reinforcement learning. And so we were researching them heavily, and we saw great scaling on data and robotics, and we were thinking about how can we do reinforcement learning in the general domain to get to a very capable artificial intelligence. And then we saw the amazing results of scaling and supervised learning in the GPT paradigm. And so ever since we've been thinking about how do we combine these two different paradigms into one.
Yeah, and it's hard to point to one exact instance where this whole effort got started, but we've had early explorations with Jakob and Shimon, we've had early explorations with Lukash, Ilya, and of course, I think one moment in time here is consolidating things with Jerry and how we can build out this large scale effort here.
So it's been going.
So the methodology they're using is called chain of thought, where basically you would tell it, here's the problem, think through the steps, say the steps, and then give me an answer afterwards. So like as humans, when we have a problem, we always think, okay, what do we do first? We do second, do third, and then we solve the problem. And that's how this AI does it. And then they apply more reinforcement learning, where basically if it gets the wrong answer, it would go back a step, rethink it. So they're doing a plan, steps, execute, plan, steps, execute, and if it's wrong, they keep going in loops until it solves the problem. And that's how they can achieve this result. Versus sometimes we go to ChatGPT and you just ask a question and you get an answer right away. It's called zero shot, where like it just answers your question right away. It doesn't think it through, so it may not give you as good of an answer.
Going on for a long time, but I think what's really cool about research is there's that aha moment. There's that particular point in time where something surprising happens and things really click together. Are there any times for you all when you had that aha moment?
Like trying GPT-2, GPT-3, GPT-4, there was the first moment when everyone was hot off the press, we started talking to the model, people were like, wow, this model is really great, and started doing something like that. And I think that there was a certain moment in our training process where we trained, like, put more compute in our realm than before, and trained first of all generating coherent chains of thought. And we said, wow, this is like something completely different than before. I think for me, this is the moment.
Wow, related to that, so when we think about like training a model for reasoning, one thing that immediately comes to mind is you could have humans write out their thought process and they on that. When aha moment for me was like when we saw that if you train the model using RL, you then get its own chain of thoughts, it can do even better than having humans write chains of thought for it. And that was an aha moment that you could really scale this and explore models reasonably.
For a lot of the time that I've been here, we've been trying to make the models better at solving math problems, as an example, and we put a lot of work into this, and we've come up with a lot of different methods. But one thing that I kept, like every time I would read these outputs from the models, I'd always be so frustrated. The model just would never seem to question what was wrong or when it was making mistakes or things like that. But one of these early O1 models, when we trained it and we actually started talking to it and started asking it these questions and it was scoring higher on these math tests we were giving it, we could look at how it was reasoning. And you could just see that it started to question itself and have really interesting reflection. And that was a moment for me where I was like, wow, like we've uncovered something different. This is going to be something new. And it was just like one of these coming together moments that was really powerful.
So
it's very funny that he mentioned that they tested it against the math models and passed the math test, because a lot of these AI companies, they actually put the math test into the training model so that they have all the answers arrayed. So I don't know if they're actually doing it, but you know, if you go test any models, most of them, they say, oh, we passed 90% of this. They still suck as a model. So it's funny that he mentioned that.
When you read the thoughts, does it feel like you're watching a human or does it feel like you're watching a robot?
It's like a spiritual experience.
It's a spiritual experience, but then you can empathize with the model. Like, oh, that's a mistake that a lot of people would make, or you can see it sort of questioning common conventions, and yeah, it's spiritual, but like oddly human in its behavior.
It was also pretty cool at some point when we have seen in cases where there was like a limited amount of thinking allowed for the model, that just before the timeout, the model was like, I have to finish it now. It's like, where's the answer?
I spent a lot of time doing competition math when I was young, and that was really my whole reason for getting into AI, was to try and automate this process. And so it's been very like a huge full circle moment for me to see the model actually be able to follow through like very close to the same steps I would use when solving these problems. And that's, you know, it's not exactly the same chain of thought I would say, but very, very relatable.
It's also really cool to, you know, it's believable that these models, they are getting on the cusp of really advancing engineering and science. And if they seem to be like solving the problems hard, you know, maybe we can call ourselves experts, hard for us, and maybe they will be even hard for some other experts and could advance science.
So we've talked a lot about some of the great moments and the times that everything just clicked. What are some of the hurdles? What are some of the places where it was actually really hard to make things work?
Training large models is fundamentally a very, very hard thing to do. And there are like thousands of things that can go wrong in the world, or at least like hundreds that did go wrong in every training run. So almost everyone here, like, you know, put a lot of blood, sweat, and tears in training those things and figuring out how to keep them continue learning and improving on their path. It's actually the path of success is very narrow, and the ways of failure are plentiful.
It's like imagine like having a the center for launching a rocket to the, let's say, some planet.
So the model we said is very good, oftentimes better than humans, like as equivalent of several PhDs. And that is sometimes a challenge because we have to often go and verify that the model isn't going off the rails, doing something self-sensible, and it started taking some serious time as we scaled the model. We were saturating out all the industry grade evals, and we don't know what to look for next. So that is also.
So what they're saying about like testing what the AI says is actually true or not at a PhD level, I think that is really true. Right now we're doing a project in the oil and gas industry, and we have this problem all the time where it's like the AI says this is the answer, and it's like, is it actually true or not? And it's very hard for a software developer to know if it's true or not. So this can require a lot of money, a lot of experts. So that is a big challenge.
So challenging.
I do think all of these things we ran into, it's also been one point of fulfillment. It's like every time you have a puzzle, it's like another hurdle for this team to overcome. And I'm really glad with all of the little hurdles that we've overcome.
So what are some of the ways you tested the models? Did you have any favorite questions that you saw the model get better at? How many hours I installed?
For whatever reason, the ChatGPT wasn't able to solve this question reliably. But O1, we did like a year and a half work, and now we can count the number of hours in Strawberry.
It's hard coded that way.
Reliably.
I have this habit, which I think other people here do too, of whenever you go on Twitter and you see some post that's like, large language models can't do this, you copy and paste it in, and then you say confirm that our large language model can do this. To give people a sense of what they can use the model for, I'd love to hear some of the ways that you use O1.
So one way I've been using O1 is for obviously coding, and a lot of my job is about coding. So the more and more I focus on the problem definition and use this what's called a TDD, test-driven development. So instead of writing the code that implements the functionality, I focus on writing, say, a unit test that specify what is correct behavior of this piece of code to pass. And so because I can focus on more of that and then pass it on to O1 to really implement the thing, I can focus on this, what's important, what's the high-level problem to solve, and so on. So this has been really an important way of shifting my focus. And
so this is a very interesting approach. I didn't really think about this, but like TDD actually does make more sense now. If you can define what the test cases are and then tell the AI to write the class to write against it, this can be a very good way to make sure that the AI is coding things according to what you want. But I think this only applies to like web apps or mobile apps. If you're trying to do more data science stuff, it won't work very well.
another area is debugging. So now when I get some error messages, I just pass it to O1, and then it just prints out something. Sometimes it solves right away. Even if it doesn't, it at least gives some better questions to ask and provide some ways to think about this problem better. So it has been really important change of working for me, and I hope this helps others too.
I like using O1 more and more for learning. The more I ask it like various complex technical subjects, I find hallucinate less and explain better those concepts on previous models.
For me, I like to use O1 as like a brainstorming partner. So that can range from anything from like how to solve some very specific ML problem, machine learning problem, to like how to write a blog post or a tweet. So for example, I recently wrote a blog post about language model evaluations, and I was asking O1 about ideas for the structure of the blog post, pros and cons of certain benchmarks, and even the style of the writing. And I think because it's able to think before it gives the final answer, it's able to connect ideas better. It can revise and critique candidate ideas and things like that.
Yeah.
So I think he's right. It's very good as a brainstorm tool, but I would also say that O1 is really slow. It takes almost a minute to give you an answer. And then also, you don't know how many tokens it's using. So when it goes live, I don't know how much it's actually going to cost people to use it versus just using the regular 4.0 model. I really think you would use O1 to basically like trying to solve very complex problems, some stuff in math and science, less of like everyone else's use case of like English, language, solving a math test, all those one-shot kind of answers. More thinking work, I think will be very useful for it.
I think if you need like you have some short text and you want it more creative, something really different, that's a great use. Like, give me 5 different ideas.
Also, if you have just sort of like some unstructured thoughts, it's a really brilliant thought partner. So you have like some ideas. It's like, well, how should I connect these things? What am I missing? And through its final answers and through sort of reading its like thought process, it can really lead to like much better results for you.
Yeah. So I think what he says is right. Like trying to find gaps. Like here's what we have. Find the gaps in this. I think it will be very good for that.
Is that you try out a bunch of our internal secret ideas and actually try to improve it.
Yeah, for standalone projects, it's great. Like I had to add a GitHub plugin. I know nothing about adding GitHub plugins, and I just said like, hey, I want a GitHub plugin that displays this and this information about the PR, and like just produce the code. I just like I would just ask it like, okay, so where do I need to paste this code? I don't even know. Like it's just like, yeah, you paste it here. Let's go.
I think for a lot of people, it's hard to really feel the AGI until you see the models do something better than humans can at a domain that you really care about. And I think for Go players and chess players that would have come a few years earlier, and for a lot of us that like really value math and coding, I think we're starting to feel that now.
Our mom's will be proud of us.
So are there any parts of this project, anything that really needed to be done, but people might not realize how important it is?
Yes, so I think building large-scale reliable infrastructure to run our biggest flagship model training runs, as well as doing research experiments, is something that is
not as exciting as doing research itself, but has to be done, and it has a tremendous impact on the success of the entire project.
I think there's something special in OpenAI about how we structure our research, in that we value algorithmic advancements in the same way as building reliable large-scale systems and building data sets that are needed either way for training those models. I'm really proud of OpenAI in that way.
I think that has been a consistent pattern throughout many of our big projects. Every time we scale a new thing up another order of magnitude, we see another host of problems, both algorithmic and infrastructure, and we definitely build a capacity to advance them both with a lot of focus.
I feel the final model is just like literally a beautiful piece of art, right? In order to make it work, we have to make sure that every step has worked, right? We find some anytime and we solve it.
There's like a word here and it.
If you're brilliant anymore.
And
one of the things I really appreciate about working on OpenAI is that from every big project like this, we really learn, right? We like this project team, people are really stronger from this particular
Organic, this project as well. The ideas have come literally from everywhere on this. I feel like
This project really demonstrated the power of new ideas. This is the right thing to do, and we should
people.
Cool to the
boring. So what was it like to give the model a personality?
Yeah, so
One thing I remember a few months ago, I remember the model was very smart, but it was also kind of boring. So what was it like to give the model a personality?
Yeah, so that's interesting. I remember that I asked model about the meaning of life, and it gave me an answer 42, which is not that bad of an answer. There's kind of similarity when I asked model, what is love? It told me, it's like a strange human feeling. With chat, then the answers start being quite interesting. That day, I asked about additional love, and it became more useful and also more fun.
So the motivation is that we want to bring the O1 series to broader audience, which we're the state of our favorite, almost on par, right, with our best model O1, but only comes with like a fraction of cost and latency. It does have the limitation that you may not know all of the knowledge in the outside world, right, which is not about science or technology, but we try to make it roughly on par with our previous best mini model, like 4.0 mini, and we are working to improve it further.
So what he says is very true. Like basically, like every time you make a new model, it's not very optimal, and to be able to bring down the latency, bring down the cost, it's a really hard problem, right? Especially if the infrastructure for maybe O1 is a lot more. So I give them props for doing that, and that is a really hard problem.
Is there anything else you've observed as we've been going through this project for the whole time we've been doing it? Anything else that's worth calling out?
I think an interesting meta observation that we've had is every model that we train is like a little bit different. It has its own quirks, and it's almost like artisanal. Because when you look at a model that can do so many different tasks, each model you train won't be exactly the same performance at each task. So it might be better at some tasks and worse at others. And so there's this uniqueness or like personality to every model that is almost like a little bit beautiful.
So overall, this O1 reaction from the OpenAI team is interesting, but not a lot of new information. I think the key takeaways are like, it's very good at being your brainstorm partner, thinking through stuff, and that's about it. I think everything else, it's